Welcome to Tech Diet. Let's dive into our today's problem. Check if there is a valid partition for the array. It says you are given a zero index integer array nums. You have to partition the array into one or more contiguous subarrays. We call a partition of the array valid if each of the obtained subarray satisfies one of the following conditions. The subarray consists of exactly two equal elements. For example, this 2 and 2, there are two elements, both are equal. It's a good subarray. Similarly, it could have three equal subelements. And it could have exactly three elements, and that should be consecutively increasing on numbers. So that means the adjacent difference should be 1, like 3 4 5. 1 3 5 is not valid because 3 and 1, the difference is 2, so that's why it's not valid. So for the current given first test case, we can partition it into 4 and 4 and 4 5 6. This partition is invalid. This is valid partition, but for it to have increasing sequence of elements, the number of elements should be 3, so this is not valid. Then we can maybe partition it as 4 and 4 and then 4 5 6. So now all the two partitions or the two subarrays are valid, so this is a valid partition, so we can return true here. Now for the next example, we have 1 1 1 and 2. Let's divide it into 1 and 1. We're left with 1 and 2. Again, this 1 and 2 is invalid partition, although the sequence is increasing, but we don't have number of element as 3. Let's just try to divide it into 1 1 1 and 2. Again, the number of element is less than 2, so that's also not a valid partition, so we'll return false here. So okay, so that's what we'll do. We'll try it out a bracket of 3, we'll try a bracket of 2, we'll check for the bracket of 2 whether we have elements equal. So for the bracket of 3, we'll check whether the elements are equal or they are of increasing sequence, and then we can further do the split. So that's how we can do it recursively. Let's maybe start with an index 2. So I'm at 0 1 2. At 2, we'll figure it out, okay, whether I can make a partition at 2 or I should make a partition at 1, because that's the only decision that we need to make. So for 2, that means all the three elements should be equal, or they could be increasing sequence. Secondly, if I made to a partition at 2, both the first and second element should be equal. So let's just write that function. For that, let's keep track of our helper function, which will have the nums as the array, and it will say, okay, where am I ending? So let's maybe call it index. So now I can say if my nums I minus 2, which is this 0th index, if this is equal to the first index, and nums of I is equal to nums of I minus 2, that means all the three elements are equal, I can do the split here and just check for the next bracket, right? The next bracket will be at let's say we have this 7, so we'll end it at here 0 1 2 plus 3 more elements, so that we have a recursion the way we have defined. So then we'll have these elements are increasing order, so the nums of I minus nums of I minus 1 is equal to 1, is the difference is equal to 1, and the difference between nums I minus 1 and nums of I minus 2 should be equal to 1. Then again we have this 3 bracket is resolved, it's a valid partition. Otherwise we can say if my nums of I is equal to nums of I minus 1, then we have partition of 2, so it should be, so this 1 and 1 are matching, or this 4 and 4 are matching, so we can say I minus 1 plus 3, which will become I plus 2. So I was at 3 index, I was at second index, so I need to go back in plus 3, so we'll land it at 6, so that's why we do the plus 2. So then we'll have, okay, each of them will return whether it was a valid partition or not. So let's just call it as A, B, and C. We'll have here boolean a is equal to false. Initially we'll say okay, that was not a valid split, and then I can then return if a, b, c, or if none of the cases match, we'll just return false. So now at this position we need to stop our recursion. So when we reach the last index, right, so let's say my whole array is done, it was partitioned perfectly, that means we have scanned the last element, and we'll return I plus 3. So if my I is greater than equal to, let's say, nums dot length, and if my I is equal to nums dot length plus 2, so we have, this is indexing, right, so last element plus 3 will do, that will be size plus 2. That means we have iterated over all the elements, it should be true. Otherwise what it could be like, if I is equal to just the size, so we have divided 4 and 4, first 3 fours. Now we'll say 0 1 2 plus 3, which is 5. So 5 is the length of array, we haven't evaluated these two, so we can say, we can return the nums of I minus 1 is are they equal. So if they are equal, then that is the only case. Otherwise we can just return false, which will be like, we have evaluated this first 4 elements, then the only element left was one single element which cannot be divided further. So for this case, 1 and 1 and 1, then we'll say okay, length is 0 1 2 plus 3, which is 5, and so it's not equal to num's length, then it's just one element is left behind, so we'll return false here. So yeah, that should do. And finally we can return our, so we are not change the data type here. It's called nums. Okay, it says time limit exceed. Okay, I had a long test case. Let's just remove that and run it again. So it says it's accepted. The initial test cases are passing. So now we'll see there will be a lot of competition that will be going recomputed twice. Let me just show you that. So we'll have a test case something like this. Okay, we'll have an array. Okay, it's failing. Why? So we have length, if there are 3 elements at the end, remaining are 2, just one left. They are equal, they should be, difference should be 1, or the last first 2 elements should be equal. Okay, the first 2 means the I minus 2. Okay, it's accepted. Now let's see the corresponding recurrence of sub problems. So let's have our println here. We'll see at which index it's getting reoccurred, or there will be a couple of indexes. So let's just keep track of 20, 23, 25, 70. Okay, we see 23, 25, which is again the series got restarted. So we need to get rid of them, right? So let's add our memoization. We'll have a dp array here. Dp will be equal to new boolean nums dot length. Just for the safer side, let's add a plus 3 because that's the max so far we can go. And here we can say if dp of I is not equal to null, I am going to return that particular dp of I, and we need to set it them as well. So we'll say dp of I will be this, and we can say return dp of I. Let's hit it again. So now we have our case 4 with no repetition of 23, 25 and 28. We saw it once, we don't have it later, so our memorization is working fine. Let's just scrap it out. Let's hit again. Let's hit submit. Okay, it says it's working fine. So here what we are doing, we are also twice sending this recursion. We don't need to send this as well. So we can say either this should happen or they should be equal, then only we need to go to the bracket of 3. So we can add this condition here and get rid of b part. Let's run it again. Let's hit submit. Okay, so this is also accepted. Thank you.